And good day, Algebra. We are going over CO4 in 15 minutes, so it's like speed running a Mario level, only with math. I can write, interpret, and evaluate algebraic expressions. This is where we're really going to take the verbal and turn it into the mathematical, or take the mathematical and turn it into the verbal. How do we take an expression, a verbal expression, and write it as a numerical expression, and how do we go back and forth? So, first of all, what is an expression? Obviously in the mathematical sense, not like your facial expression. But what's an expression? Yeah. Well, an equation's different, right? An equation and an expression are two different things because an equation has an equal sign, right? It tells you two things have an equal value. An expression is really just a collection of terms. And by terms, I'll kind of expand on that, put numbers and variables with operations thrown in there too, right? But it's a statement. It's a mathematical statement. Okay? 3 plus 2 is an expression. 3 plus 2 equals 5 is an equation, right? Because you have what 3 plus 2 equals. But it's basically a collection of numbers and variables and throw some operations in there as well. And speaking of variables, what is a variable? What is a variable? Catherine. That what? What's its purpose? You're right. We use n, we use x, we use y, we use z, but what is it? Why is it there? What does it do? You know, Claire?
A letter that represents the number that we're trying to figure out.
Right, and we usually use a letter, but really a variable is any symbol, but usually a letter. 2 L's. There we go. Spelling bee champ. Actually, not spelling bee participant, but that's okay. A symbol, usually a letter that represents an unknown value. It's a symbol, usually a letter that represents an unknown value. And really, any letter can be used. Most typically, you'll see N or X or Y or Z, A, B, could be C, sometimes D. I've seen F. Yeah. Don't forget about E, though. E's in there, too, sometimes. G. H could be used. You can use H. Yeah. Yeah. Even I. So, we will begin by going through this table and getting to know some of the phrases that mean these main 4 operations. Because whenever we want to add something, we don't always say just plus, right? There are other ways to say addition, such as what? What's a word or phrase that you've seen before that's used to represent adding 2 things together? Kylie? Added to. Okay. Any others? Together? You gotta be careful with that one because depending on what precedes it, it could mean other operations also. So together by itself doesn't mean addition necessarily, but Anthony? Sum. That means the answer to an addition. Okay. Let's open it up to the other 3 operations also. What are some things that you know mean subtraction, multiplication, or division? Liesel. Minus for subtraction. Okay. And I'm going to be kind of picky with subtraction because there are a couple that I want to point out specifically. So in the same box as minus, if you've got room, I want you to also write difference, which is the answer to a subtraction problem, the difference of something. But I'm going to be kind of picky with the other ones, so maybe say that. But yeah, Damien. This is a key point, so it is eligible for a help sheet, yes. Alex. Times for multiplication. Okay. Good. Ellen? Quotient for division. That's the answer to a division. What would be the answer to a multiplication? We'll kind of just stay in that same vein here. Bryn? Product is And the answer to a multiplication. Kylie, what you got? Of. Yes, and the word of by itself does mean that you're multiplying, but oftentimes you'll see the word groups there. So groups of, 6 groups of 8. How many are there total? There are 48. When we talk about multiplying fractions by wholes, 1/4 of 12. Okay, that's 1/4 times 12. You could look at it like that. The word groups, though, is interesting because you can also use it for division, right? Within 2 groups. Put 48 things into groups of 8. You'll have 6, right? So groups of into groups, but that word of by itself does mean multiplying. What else you got? What else you got? Ellen? Okay. Sorry, what did you say? Plus. That can be addition. Okay, kind of our standard. Yeah? Divided by for division. This is a good list, and I'm going to keep the last ones open in case we come across others. Then we'll have an extra space. But I want to go back to subtraction here because this one can be a little bit tricky. Okay? The phrase less than, okay, is one that can easily trip you up when it's used in a verbal statement. If I say, a number less than 20, a number less than 20. You might hear that and you might think a number less than 20. That would be a number less than 20. N minus 20. No. Right? Because if you have some number less than 20, that actually means you're starting with 20 and you're taking something away from it. Right? A number less than 20 is actually going to be 20 minus n. Because you're starting with 20 and taking some number less than that. Okay? So when you see the phrase less than, it's going to be kind of backwards from how it's written. And you're probably looking further down the page and you're seeing an example of that. Okay? The other two that I want you to be careful of are subtracted by versus subtracted from. Okay? Subtracted by versus subtracted from. They seem like they'd be the same thing, but they're not. What is the difference between subtracted by and subtracted from? 10 subtracted by 6 versus 10 subtracted from 6. What's the difference, Aiden?
Subtracted by means that the number is first, and subtracted from means that it's last.
Right. It's subtracted by, it would be in the order it's presented to you. 10 subtracted by 6 would be 10 minus 6. Whereas 10 subtracted from 6 means you're starting with 6 and subtracting 10 from that. So these two here, less than and subtracted from, are the two that if anyone's going to trip you up, it's going to be those. Because the order in which it's presented to you is backwards. Okay? Lisa?
Like away from you taking 6 away from 10 would be subtracted from.
Yes. Subtracted from, you're actually taking 10 away from 6.
Subtracted by.
Right.
And then like the other way around.
Yes. It can get confusing. This one, the order really makes a difference here. So you got to read it carefully when you're dealing with subtraction. Jack?
For addition, there's and.
Yes. You got to be careful with that one too. Because you could have the product of 7 and 9, right? That and is the product of something. So you got to be careful with the word and. But a lot of times, if you just hear it by itself, 3 and 5, right? It means that you're adding. Max?
For addition, sometimes it's going to be total.
Total. Okay. Good. Yep. We'll leave those other 3 open just for later on. But I want to get down to the practice if that's okay with you. Alex, is that okay with you? Please. Okay. All right. Well, let's get down to the practice. We've got, let's see, directions say, write the verbal phrase as an expression. Evaluate when n equals 2. So the quotient of 16 and a number, we see the word of there, right? But it's preceded by quotient, which tells us that we are dividing here. Does the order matter when you divide things? It does, okay? So 16 and a number, it's important that we put that 16 first. 16 divided by a number. If you want to write that vertically as a fraction, it's going to be 16 divided by a number. Either way is acceptable. When we plug in 2 for n, in both cases, we get 16 divided by 2 or 16 divided by 2. We get 8 as an answer. Okay? Let's look at the one right below that where it says 12 times a number minus 3. Something we haven't talked about yet is the comma. And the comma is a pretty important part of reading an expression and turning it to the mathematical. Because what the comma does, it kind of acts as parentheses. You know, if I just read this to you and you didn't see it, you just heard it. I said 12 times a number minus 3. There are a couple of different ways you can interpret that, right? You could think about it as, okay, I'm taking 12 times a number and then subtracting 3 from that. Or you could say, well, 12 times a number minus 3, I'm taking 12 and I'm multiplying that by a number minus 3. Right? Those both kind of say the same thing, but they're going to give you very different answers. So looking at the placement of that comma, which one is it? 12 times a number, comma, minus 3. Joey? The first one or the second one? The first one. Yep. Okay. What that comma does is it kind of separates that 12 and a number. Do that first, and then subtract 3 from that. Okay. So commas are very important to pay attention to as well. If we plug in 2 for this, 12 times 2 minus 3, 24 minus 3, we get a value of 21. Okay. Questions? Okay. Yes.
I'm still kind of confused by like the how the comma how you for sure know it.
So if I wanted this second one here, if I wanted the n minus 3 in parentheses, I would want my comma probably here, right? Because then it would say 12 times the number minus 3. It kind of groups that number minus 3 together, which would tell you that you would need parentheses. Okay, so what the comma does is kind of separates the two parts of it. Yeah, Max.
When it says like sum, does that mean you have to add it before like sum is kind of like a parenthesis?
Yes. Yep. The word sum can be interpreted as kind of like a parentheses. If you're looking ahead and seeing that, yeah. Lisa.
I'm confused on the two to the right that we did. Like the top one in the bottom.
The product of a number in -7 and twice the sum of a number in 6?
Yeah.
Don't worry about that. We'll cover that tomorrow. There'll be no homework tonight. Other than, hold on before you, okay? You've got Khan Academy that is due tomorrow, so you haven't done that yet. Tonight would be a good night to do that. You've got entrance exam practice work to work on, so with our need daily math homework, tonight's a good night to work on that. I've also posted the football pick'em sheet for week 3. Standings will be printed out and posted next period, so you can stop by later for that. But week 3 is in Google Classroom for you. Any other questions, comments, concerns, complaints, comments, congratulations, or criticisms?
Why do you say congratulations?
In case you want to congratulate me.
Thank you for teaching.
Teachers need self-esteem boosters too. All right, folks, that's all you math.